Hello, Algebra 1, Lesson 19. We are on day 3 of 4 interesting transformations of functions. First we did absolute value functions. This would be up and down. Then we did absolute value functions left and right. So here we have up and down. Here we have left and right. And now we're moving on to just a little bit harder. We're doing horizontal scaling. Horizontal scaling. Oh, step backwards a little bit. Here we also, let's find another color. We did a value out here. I can't use K again. Dang it. They use K in the curriculum. I use something different. All right. We're going to use it in purple. Sorry, just a little review, so this isn't learning it for the first time. We would do either 1 over K for a vertical shrink. Remember, it gets wider when it's 1 over K, or just plain old K, where it's a vertical stretch, where it gets skinnier and taller. All right, now we're doing horizontal scaling, which is going to be in the inside of our absolute value sign. Or what we're going to do today is going to be on the inside of our quadratic or parabola. All right, so that's what we're going inside of things now, and it's hard. Horizontal is hard because it's on the inside. All righty, moving on. So to begin, we have our function, f of x equals x squared, and we're going to say g of x equals f of 2x. What we learned quite a few lessons ago is when we see that, we need to replace our x with 2x. So I'm going to use some parentheses. We know that g of x equals parentheses 2x squared. So instead of x, I write 2x. X equals 2x. I substitute. Okay? Now we're going to complete the table of values for these functions. I have f of x equals x squared, and g of x equals 2x squared. So x squared is easy, negative 3 squared, 9, 4, 1, 0, 1, 4, 9. 2x squared, just a tad bit more complicated, but not impossible. 2 times negative 3 is negative 6. Negative 6 squared is 36. Negative 4 squared, 16, 4, 0, and then it just repeats. And there we see there, yeah, nice. There we see the answers, and now, amazingly enough, we're going to graph these. Notice I'm all on the positive y-axis. So graphing these, I'm going to graph g of x in purple and f of x in red. So f of x equals x squared. Go back to my chart. I've got negative 3, 9, 2, 3, oh, and great, 9 isn't even on my graph. So let's do negative 2, 4. Negative 1, 1. 0, 0, and then we reflect over, and we see our parabola. X squared always looks like this. This right here is the parent function for x squared. Always looks like that. Just like our parent function for absolute value x was always a big old V. Now if I do g of x, again, 36 and 16 are not on my graph, but if I go negative 1, I'm going to go up 4, positive 1 up 4, and 0. So we see the pattern. G of x is on the inside. And there we see their graph. Excuse me. What we actually see, I had g of x equals, in parentheses, 2x squared. That right there is a scale factor of 1/2. Like I said, horizontal is hard, so when it's inside the parentheses, I get my scale factor by taking 1 over the number that's in parentheses. Okay? So this scale factor actually shrinks horizontally. So it shrinks the original graph by a scale factor of 1/2. Okay, horizontal scale of the graph by 1/2. So if what we see here, and I'm going through these numbers, if we find x on the x-axis, we multiply x by 2, so our value 1 goes to 2, to find the number 2x on the x-axis. And then you find the value of f at 2x, and it went up by 2. So multiply by 2, hit it, and it multiplies by 2. But we are actually shrinking horizontally. If I think about the x-axis is horizontal, this actually, think about, shrinks in. Let's see if we can do this. It shrinks it in horizontally, so it pushes it in horizontally by shrinking. Horizontally is always our x-axis, so if I could get 2 pens going at the same time, I would. I'm pushing it horizontally this way and that way with a horizontal shrink, which looks the same as a vertical stretch, but don't get those confused. This right here is called a horizontal shrink. Just select my right pen again. There we go. So how does the graph of y equals g of x relate to the graph of y equals f of x? So the x value of y equals g of x is half the x value of y equals f of x. So that would be that horizontal shrink. How are the f values of f related to the values of g? So the outputs, find the outputs of f and g. So at the outputs of f and g, the input of g only has to be half as big as the input of f. Okay, that's that horizontal shrink. Alright, so let's try a different one. So now we have let f of x equal x squared and h of x equals f of 1/2 x. So here we have f of 1/2 x. So I'm going to do 1 over 1/2, which is 2. So my scale factor is 2, which is a horizontal stretch. Okay, like I've said, horizontal is hard because when it's in the inside, I have to do more work. It's not really hard, but that's how I always remember it. Horizontal is hard because I have to do more work to find my scale factor, which here is going to be a horizontal stretch. So h of x equals 1/2 x squared, which is 1/4 x squared. Let's go ahead and do our work. This is the same, 9, 4, 1, 0, 1, 4, 9. Change colors. We're going to go with, let me get my purple back out. Do our math. I've got 2.25, 2 1/4, 1, just a quarter, and then reflect. And let's graph it. There's the values, check. and graphing it. Let's do f of x first because it's not going to change. Negative 2, 4, negative 1, 1, 0, 1, and 4. It's a parent function, always the same. It's a big U opening up. Now our other one, we're going to go negative 3, 2.25, negative 3, 2.25, about right there. Positive 3 up to, that'd be 3, 2.5. Just want to make sure I get it right. 2.25, negative 2, 1. Negative 1.25, and then 0. Okay, that 0.25 is a little off. But here we've got a horizontal stretch because we stretched it out in the horizontal direction. Changing pens. Oh, we got our graph. Check. So how does the graph of y equals f of x relate to y equals h of x? So the corresponding x values, oops, sorry, I thought I changed my pen. So the corresponding x values of y equals h of x is 2 times the x value of y equals f of x. We've got a horizontal stretch. How are the values of f related to the values of h? These are the outputs. So to get equal outputs of each function, the input of h has to be twice the input of f. Okay, cool. So let's practice these for a few. Oh no, sorry, now we're doing exponential. Lots of stuff going on in this lesson. So let's just input and compute, okay? We're just going to plug and chug, okay? So you got negative 2, plug it in, find your function. Here I've got 2 raised to the negative 2, which is the same as 1 over 2 squared, which is 1 over 4. Then I have 2 to the negative 1, which is 1 over 2, 0, and then 2 to the 1, and 2 squared. I'm going to erase those so I have a place to work for my other ones. If you didn't get them down, you can rewind real quick. Now I'm doing g of negative 2, 2 to the 2 times negative 2, which is 2 to the negative 4, which is 1 over 2 to the 4, which is 1 over 16. These are all exponent rules that you are supposed to have memorized. G of negative 1, 2 to the 2 times negative 1, 2 to the negative 2, 1 over 2 to the 2, which is 1 over 4. 2 to the 0 is 1. Oh, goodness, that's wrong. Haha. Oh, and then I sort of erased that. Sorry. I'm going to replace that one. 1 half. Anything raised to the 0 power is 1. Silly me. Sorry, I got a little quick on my writing. 2 to the second power is 4. 2 to the 2 times 2 is 4. 2 to the fourth power is 16. All right, let's get some room. Again, if you didn't get that written down, you can always rewind and get them written down really quick. And use your pause button too. Okay, now we have 2, oops, it's h. So h of negative 2 is 2 to the negative 2. which is 2 to the second, which is 4. H to the negative 1 is 2 to the negative 1, which is 2 to the positive 1, which is 2. Then we have h of 0 is done, h of 1, 2 to the negative 1, which is 1/2. And then h of 2 is 2 to the negative 2, which is 1/4. I'm going to talk through these with you, though. Hold on. All right, I had to get my numbers so I could look at it. We're going to graph these. They're already graphed here, but I want to show you where everything goes, because if you just assume you know it, you might not. So let's do f of x equals 2 to the, haha, oh no, there we go. F of x equals 2 to the x. So x equals negative 2, y equals 1/4. That's why we're way down here, pretty close to the x-axis. Negative 1 is 1/2, a little bit higher. 0 is 1. Notice they all go through 1. 1 is 2, over 1 up 2, over 2 up 4, over 3 up, 2, 3 up 8, etc. So it's exponential. Now let's look at the purple one. Negative 2 16th, so it's even closer to that x-axis. Negative 1 1/4, so it should be below the blue graph. Goes through the 1, and then we're going to grow faster. Okay, still exponential, but it's going to be a vertical stretch or horizontal shrink. I can't get the K in there, sorry. Oh, now I'm blue. Ah. All right, let's look at h of x. Look how we reflected. So negative 2, x equals negative 2, y equals 4. So we're coming up here. X equals negative 1, y equals 2. Now we're going to get smaller and smaller. X equals 1, y equals 1/2. X equals 2, y equals 1/4. So that is also exponential. But we reflected over the y-axis. That negative in the exponential spot reflected it over the y-axis. And it looks like we just reflected f of x equals 2 to the x is what we reflected over the y-axis. Changing pens. So describe the transformation of y equals f of x to the graph of y equals g of x. So y equals g of x is a horizontal shrink with a scale factor of 1/2. And then we have y equals f of x and y equals h of x. That would be our reflection over the y-axis. And now it says write a formula of an exponential function whose graph would be a horizontal stretch. Well, if g of x equals y, nope, I don't know why I said y, x to the 2x, right? Double checking, yep. To the 2x, and it's not x to the 2x, it's 2 to the 2x. This one is the horizontal shrink. To get a horizontal stretch, we would have to do something like that. That's an E. Yep. All right. Exploratory challenge 3. So I've got like 3 questions left, and then we're going to review. If I look at the graph of y equals f of x for the function f of x equals x squared in Exploratory Challenge 1 again, would we see a difference of the graph of y equals g of x if negative 2 were used as the scale factor? No, there's actually no difference because we are squaring, which a negative times a negative is positive. So when we square it, it becomes positive, and it's totally fine. We had f of negative 2x. So if I put it in there, it was a g of x. Negative 2x squared equals 4x squared. Okay, no difference. A reflection across the y-axis takes the graph of y equals f of x for the function f of x equals x squared back to itself. Such a transformation is called a reflection symmetry. What is the equation for the graph of the reflection symmetry of y equals f of x? If we reflect over the y-axis, we are actually reflecting on the inside. That would be the y reflection, where in the past we had y equals negative f of x is the reflection of the over the x-axis. That's the x-axis reflection. Here is the, I don't know why I did that, y-axis reflection. This right here is a fantastic summary. I would write this down so that you can remember the 4 different cases and what happens to them. For case 1, when k is greater than 1, if we have y equals f of k x, this is a horizontal shrink by a scale factor of 1 over k. It's hard. We have to do some work to get our scale factor. For 2, y equals f of 1 over kx. See how we're a fraction? This is a horizontal stretch by a scale factor of 1 over k, which is just plain old k, right? And then when we go negative, we have to do some reflecting. When k is a negative fraction, we reflect over the y-axis. And then when k is a whole number and negative, it's the same as number 1, and reflect over the y-axis. Awesome, good work.